Yes, thanks for having me here. I'm Norwegian, I'm not Scottish. I studied 2 years in Glasgow Uni, but that's a long time ago, so my accent is gone. It says about R5 chain, but actually the R5 issues we started to have on the Norwegian side is more like a tip of the iceberg. It's there's many underlying causes, because as things changes in the industry, sometimes we are not catching up to the changes and the way we work fast enough, so that we sort of, and somehow something else emerges, we also have to look at the whole total picture. So I'm going to speak a little bit today. Some of my slides contains a little bit of text, which I normally don't do. But that's because the handouts. So if some of the slides have some text, don't read it. It's more like about conveying the messages afterwards. So as I said, the rules and standards shall reflect industry learnings. This is typically what they focus on, things that goes bad. Always things goes bad. It's interesting, but also look at what goes well. What are we doing correctly? The combination of that is normally what drives change, what works and what doesn't, and why doesn't thing works and why does certain other things work. And what got us here won't get us there, and this is very often important to remember, and also for the anchor handling industry. We have been doing things as we have been doing for many years, while the outside parameters are changing. So if you look at how we were anchor handling, can you read this? It's a little bit poor resolution here, but we were, if you go back to 80s, 90s, the rigs were actually moving around with the chains in the lockers. Simple line assemblies, you normally run out chains or wires. We didn't often put extra inserts in there. There was very few buoys. We wet stored it. We had low presetting loads. Had no high-strength steel issues, normally max R3S, R4. And the inspection regimes in the industry was made for that situation. Every 5 years, the rig came in, we looked at the chains, we looked at everything. And then we started to prelay, and things changed. Of course, speed was the key. So for the anchor handler to get the contracts, it was always popular. Yeah, safety is good, but if you can work fast, the vessels who got things deployed and back up the fastest and best effectively tended to be favored by the operators for the contracts. This is how it works, and it, I guess, works today. And then we started to do prelays, much more complex line assemblies, 3-kilometer lines with fiber inserts and buoys, and really horrible if you look at it, because the driver increased the anchor loads, increased the safety factors, modified things, and introduced high-strength steels, which carry their own issues. So around 2010, the anchor loads also were increased, especially on the Norwegian side. Since then, we haven't had any dragged anchors on the Norwegian side, but we failed a lot of equipment. So basically, the pendulum swung the other way. The problem was dragged anchors, many issues. Now we have issues between the anchor handler and the anchor. The anchors are normally staying, and they stay well. Larger vessels, smaller margins, high line utilizations. Yes, good focus on crew and vessel safety after the Bourbon Dolphin incident, stability and how to work safely. But still, this is there. If the vessel who works the fastest, the most effective, have been the most popular ones. I'm not saying that will change, but we have to look at the way we work, because all the outside parameters has changed. So, and also the fact that chain cannot take everything you subject it to. It just appears so. So why we focus on this from the class side? Well, It's about equipment integrity. Now we have equipment suppliers, things are going loaded out, loaded in, moved around from one spread, from one operator to one rig. And if you don't know where this component has been or going, you have to treat all of them equal. And the fact that we're then having more loading, more higher recovery loads, it's a challenge to follow up these ones in service. Of course, what we don't want is multiple weakened lines in a mooring spread. To have one line failure is fine. It doesn't really ruin the day. The integrity is there, it's designed for it, but to have multiple weakened lines because of handling defects and other past damages, so one line failed, the next line failed. That's the situation from a sort of safety aspect we like to avoid. To lose a line is a cost. It's not critical. And of course, if components are failing under low load, lower than they should be, that could be a crew safety. So if you're working on the deck, yes, clear deck policy, and you're running out chain, and it falls apart under its own weight because it has been weakened. Are we then out there or not? That is the thing. And even if it fitted in the shark jaws and it snaps just beneath the stern roller, there is a snapback. You got people with the fingers and hands inside those chain links fitting bolts and nuts. Suddenly the thing moves in maybe in 100 tons, just the weight of the assembly. That's a killer. And that's what we're getting if we are not changing the way we work, because the number of incidents accumulates, and sooner or later it will happen, a failure at the wrong time on the wrong location. So this is, again, this is what happened just when I change snaps under low load on the roller. It comes a snapback. And this was about 100, 150 tons. I have many videos of this, but this is the only video I actually have permission to show. This is from Equinor some years back. It just shows the forces at play, and it snaps just beneath the stern roller where the loading is the highest. So what we're going to talk about is phase operation, the focus areas that we're working on. That is the installation and anchor tensioning. And not necessarily the tensioning loads, but how we conduct it over, because we tend to overdo it. We tend to stay above the 15 meter, the max tension. Marine warranty and the company's focus is that we should never be below 350 tons or 400 tons for 50 minutes. But actually, the intention was actually to be around that load. So we are overdoing it as well. Recovery, I'm going to speak a lot about the recovery loads. This is the main driver for the change. Load monitoring, to be able to inspect properly, we need to know how the chain and the components has been used and what loads they have been subject to. It's not to look the anchor handles in the card, it's basically just to make sure we get the information we need to inspect it properly. And then we got the recovery procedures. Ryhov's going to talk about that later on. It's come now into GOMO. That in the old days, it was like how to pick out it was 2 lines. Anchors to be recovered at your convenience. We send an anchor handler to pick up. But actually, 90% of our failures and fatigue comes from the recovery phase. So that's the phase we need to control rather than the other ones. Then, of course, I'm going to talk a little bit about fatigue. Steve told me to go basic and focus on the whys. So this may be horribly basic for some of you. This is what I normally do with some of the captains as well. But when you're pre-installing the lines and if you tension up the anchors, there's always a lot of slack in the line because you have long lines. The weight of the assembly causes that. So there's not so much additional tension. Whatever load peaks comes for the vessel motions can be compensated for by the weight and the flexibility in the line assembly here. But if you look at the as I said, the anchor loads, we try to, the DNV interpretation is to be roughly around the target, because you will have fluctuations. Industry tends to focus above, and sometimes the loads are so high, we have to do parallel installation, tandem, 2 vessels working, and there's no load cell in the line. There's 2 vessels trying to optimize their bollard pull to achieve a load, and then we're happy. So it's not very scientifically done either. So we're trying to get away from this tandem operations, using 1 vessel, try to get the loads down. That is one of the long-term targets. The main core of the failures we had, and not just the R5, is actually the recovery loads. If you are in a 100 meter water depth, you have a chain. In this case, there's 100 meters of chain. You have a tension on the roller, about 200 ton from the winch. And if you tension up a murmuring chain about 100 meters to 200 tons, it elongates about 70 centimeters or something, because it almost up to the, it takes out all the slack. And if you go on and pull more, in this case, I just show what happens when you force the motion 2 more meters. Then that chain has to elongate 2 more meters, because the anchor isn't coming. And just by that additional 2 meters, because the stern was rising, I go from 200 ton to 800 ton in my line. That's not captured on the winch necessarily, because my brakes are on, my load cells are not calibrated. So I am up to yield in part of the chain. And if I'm over the stern roller, that's even worse, because these links over here, cannot meet the MBL, because they are twisted over a roller, have a different stress inside. They don't handle the MBL normally. So these over here may have other damages. They're also friction, high temperature, moving along the roller, hitting the pins. So that's where many of the damages occurs. And for R5, this is particularly bad, because those friction forces causes something what you call untempered martensite, and that is what causes the HISC in combination with other factors. So this picture comes into play as well. And just to illustrate this, I can play that video, I think, if there's a, again, I'm going horribly basic here. I apologize to some of you, but this is a presentation I sometimes try to optimize. This is basically how you take out the slack, reach 200 tons, and then you continue to elongate the chain. And this is basically what's illustrated here. This is only for 2 meters elongation. And we all know that when a vessel is working on a tight chain in HS of 3.5, it doesn't move just 2 meters. It moves a lot more, 5, 6, 7 meters up, forward, and that chain has to take it. So either the anchor comes, but it doesn't come that fast. You will elongate the chain, and you will introduce damages on the links on the roller, but they're not visible. You may see scratch marks, but you can't see the effect of those scratch marks. You don't even know the effect of the scratch marks. So this is just to illustrate between 300 meters and 100 meters water depth. And you can see that here your loads of the red line is very bad resolution. Yeah. You can see the red curve is in 300 meters, 3.5 meter HS. If I move to shallow water, 100 meters, the loads are fluctuating because of the stern motions. And you see, you're aiming for 200 or 250, and we're getting up to 550 peaks, which is not good for the link. And this is why we require it to have a work chain over the roller. So that takes the effect. So the rest of the recovery line only takes the tensions, because chain can take tensions. It's not very good when it's been wrapped over something. Yeah, this is just a few hints. And maybe the important one is, maybe not all anchor handlers should be recovering mooring chain in bad weather, because the winch may be too stiff. There's no dynamic. You have to use brakes. You can't go on tension control. There's no way you can go because your gearing is too high. You don't have enough oil on your engines. So that is something we are working on. So Equinor says, well, maybe we should wait a couple of days till the weather comes down. Then I can send the vessel I have available. Not just send as soon as I have it and pick it up in a 3-meter HS, because then that's where we introduce those damages. How am I on time, Patrick? Good. I can just go on to it, because I sometimes tend to. So basically, it's the stern accelerations. If you don't have much motions, you don't stress the chain. If you've got motions, you will stress the chain on the recovery operations. Not going to talk about this because Ryof's going to come. Now this is from GUMO. There's requirements to recovery procedures. So if you plan to put an anchor in, you also plan how to get it out. And to get that out an anchor, you should be able to get it out below 250 tons. It's been tried a lot now in the Norwegian side. Equinor has run a lot of tests. Del Mar and Intermor knows about all this, but it works. By being patient, letting things soak up, and let the soil, the compressed soil, soak up before you pull more, you should be able to recover your anchors with less loads rather than using brute force. Because if you're using brute force, you're pushing out the water in the soil, it just gives more resistance. If you give it time, keep a tension around 100, 150 tons, and the water will dissipate, and you can tilt a little bit more. If you keep on pushing towards the surface, that's when you get these high loads. And you have to avoid those load peaks, because that's what's killing the chain. So that's out last year. That gives, I think this is actually from Ryhoff, and this is also implemented into the GUMO, how to recover anchors. So load monitoring is what we need. And this is a problem in the industry because many anchor handlers don't really have a display on my load history. How am I going up? This is taken from one log where you see there, this is a pre-installation. You're pulling up the load, you're holding, and then you unload again. To see that graphically, not all anchor handlers can. Normally it's just a number flashing on a screen from sometimes uncalibrated load cells. So what you go by is a bullet pull charts, and they are not accurate enough. They will not give you the peaks. That's what they did before, but they can't do it anymore because it doesn't give us the peaks. So this is, and also we build the inspection regimes on those logs. So that's why we're requesting now the logs from the anchor handler for each spread that goes back to the approved service supplier like Del Mar and Intermor. And they use those logs because they know where each component has been in the line. So they know which part was part of the recovery. And if they see the load charts and they see high loads, okay, then I need to inspect more on those links. If the loads are low, they don't need to do any extra inspection. This is again, it's an EP Huse winch, anchor handling winch. And there's a small number up there flashing. This is from the control screen. That is what we want to have the history of. The load cells and setup shall be calibrated because it is so that depending on the configuration of the winch, what mode you're in, it can be tension control, pressure differences, it could be direct load cells in the brake foundations. They come with a plus-minus accuracy. So we should know what kind of mode I'm in will tell me how accurate my tension measurement is. That's also an important aspect. So rather than seeing one flashing number, we would like to have a screen, and some of them are now upgrading, I think, some of the vessels to have a little bit more control of what they're seeing. Yeah, I'm not going to say so much about it because you can't even read the text from here. It's too coarse. But as I said, the accuracy here depends on the winch. If you got, do you have enough oil? The gear, if you have high gearing, the motors are spinning. If you're on tension control, and if you are in bad weather with a stiff winch, you will run down your winch. The engines are running too fast. You can't fill with oil. That's a disaster. You have to go back for a long, long off-hire. So to prevent that, it's safer for the vessel to turn the brakes on. If you turn the brakes on, we get the other situation where we actually are stretching the chains. We have to find a middle way. So the easy one is to make sure we don't recover the anchors in bad weather. That helps a lot, and also use different techniques. This is something the designers of Rolls-Royce may have dreamed up, but this winch is slightly oversized, but it's for illustration purposes only. And that is, when it moves, if you have a high gearing ratio in the gearbox over there, the vessel moves 1 meter, those engines have to run fast to catch up with the load. And you can just run that video. This is just to show the tension control, how the system is supposed to move in and out when you're in tension control. But of course, this is nice weather. If you're in really rough weather, it depends, again, what winch do I have. If it's too stiff, I'll be on the brakes. Otherwise, I end up ruining my hydraulics and going for off-hire, and nobody wants that. So that's the trade-off. That's why we need to know the loads afterwards. So if sometimes the vessel have to turn the brakes on, but then we like to know what were the loads so we can actually inspect that, because there's not much, maybe 150 meters who's part of the recovery. That's where we like to inspect, not the whole chain. Yeah. Again, goes on optimum use of rendering. There's not so many captains in the audience, is there? No. Any anchor handling people here? One there, 2, 3. Okay, not so many. So you know all this, but there's a little bit challenge also to the suppliers of the winches to provide with information. It's also now in GOMO. What's my winch capabilities? What's my optimum setup? That hasn't really been the case before. And this is down to the core of it, because to the left there you see a classical counter shackle. You can see the cracks we see on the T. But the mooring chain, the challenge is that this is actually taken from the workshop in the DNV lab. These are high pressure cleaned. And I know one of the links, there's 5 links lying there. One of the links is cracked 75% through. I'm an experienced DNV guy, but I can't see the cracks because they're so fine. I can only see it on the T. And this is, as soon as we start to open up a crack and it goes, the only way we can find it is when it's split or by using NDT. We can't inspect 10 kilometers of chain park with NDT. You know, it's not technically feasibly economically done. This is why we need to be a little bit more targeted inspections. Which part of the line has been subject to high loads? That's why we focus and leave the rest. So this is how difficult it can be. And so the solution is not more inspection, but less damage. So the challenges with cracks is that you may have small surface cracks from drag marks, which is, if it's a high-strength chain, something hitting the edge of the chain locker, hitting the edge of or hitting the towing pins, or a twist on the roller or whatever. Something happens onshore. You may get small surface imperfections. And if give that time, and it will corrode and blunt away. So that's why wet storage maybe wasn't so bad, because then some of these crack starters will actually corroding away. But if it goes beyond a certain level, that crack will tend to grow. So every time I have this on the recovery, I go up to high loads. The crack, every time I'm riding on an anchor, the crack goes. For every load cycle, the crack goes a little bit more. And after a certain point, it will never stop going, because now I've reduced the capacity of my chain, and it will continue. And if it's high-strength steel, the R5 issues, the crack can even continue to grow while it's stored on the quayside, because the hisk may be driven by the corrosion process. That is something we're still looking into. So that is something that if you damage it beyond a certain level, it will continue, and one day it will fail. And hopefully not while we have it on the stern roller, crew working on the deck, and it fails on maybe 100 tons or something, low load. We consider it safe, but it's not safe. It snaps back. Because you can't do NDT on all this stuff. It's not technically possible. So this is why we're then having new inspection schemes in the DNV, going completely away from our old schemes, and we go on more targeted inspections. Because to look at a chain that has been used for many recovery operations every 5 years it's not catching it. So you have to leave this to the equipment owners, and they need the data logs to be able to pick out the sort of high candidate for damages. Same as the onshore handling. There's a requirement to onshore handling as well. When the anchor, that includes the phase when the anchor handler is collecting the chain. Don't drag it at high speed on concrete, because that causes friction heat. Friction heat may cause a small micro surface damage, looks as scratch marks. That is what you call untempered martensite, and that is where the hisk, if you've got R5 chains or R4S or whatever, can start the hisk process. So I'll show a little bit about that afterwards. Yeah, that's the new motto, drag with care and no snag. So the R5 issues, which was really what triggered all these discussions, but actually that was just the tip of the iceberg. It was actually the way we were doing things that suddenly showed bad when we got all these R5 issues on top. And that could be as easy as small scratch marks, as I said, friction heat. It creates a small, thin layer of untempered martensite. Extremely, this is seen on a microscope, with small surface cracks. And if these are supplied with hydrogen, or there's a wire lying over it, or as the ICCP systems as well can actually cause this, these cracks will grow. This is why I don't like R5 to be on the stern roller during recovery operations. We like to have a work chain or something lying over there, so that takes the punishment and we isolate the R5. Because give this time, they will grow, and they may be self-driven. So there's nothing wrong with the R5, but it's high-strength steel. The hardness values are just below the level where hisk is a risk as per the industry experience. And if we are treating it where it's hitting, damaging, then it may go over in the above 350, 360, 400 hardness values, and then it is susceptible to hisk, to hydrogen cracking. This is slightly more explained. Basically, it's to keep the friction heat down. That's why we don't like the R5 to be moving along on the stern roller or drag the high speed on the quayside, and also impact the damages, because the drag marks are typically just a very, very thin layer marked with red there. And then if you have an impact damage, there may be a microstructure damage 1 to 2 millimeters beneath. You can't see it, but if you cut up in a microscope, you may see it. But that microstructure change may also open up that high-strength steel to hydrogen cracking. So those are the mechanisms why we have to treat the R5 a little bit nicer. Don't use it on the bottom chain for recovery. You don't have that over the roller when you're working. Otherwise, R5 there's nothing wrong with the R5. Still good on time? No? Okay. So basically, DNV made rules for onshore handling. That includes the loadouts, how the chain shall be handled onshore. I mean, together with industry. This was based on a workshop with Intermor, Delmar, Solstad, DOF, rig companies, and the operators. So it's not something we dreamed up on our own. This is actually the fruits of collaboration. But DNV was given this sort of role to facilitate and put it down in writing, because in the end we are people who write rules and stuff. So, and also the offshore handling, how you shall recover anchors, what you shall do and not do. Much of this is now into the latest edition of GUMO. But then that has gone into the DNV service supplier scheme. So the larger owners of equipment, they are being certified to, basically DNV is technically stepping 1 to 2 steps back, approving the equipment owners and their procedures and way of handling the equipment, and then we're auditing how they are following it up. So it's not like we are coming up every 5 years or every time there's something, because that turned out to be insufficient, then we do a lot of prelay. We were basically coming too late. Things would fail before that. So I'm not going to say so much on the schemes today, but this is typical. And if you read the numbers, this is from Equinor, and I think also Delmar did a comparable study. And this is, I think, the recovering anchors on the troll field. Maybe somebody in Delmar can confirm. I think that's what Equinor did. Where they sometimes struggle to get the anchors up because you set them so deep, it's hard to get them out. You're riding on the anchors. This was 3 hours. And this was theoretical studies compared with logs from the anchors. So they're actually doing physically tests offshore, testing what are my loads, how long do I have to spend doing the old way. And after 3 hours, basically with those loads, the fatigue capacity of that mobile mooring chain is 18 hours, theoretically. And we had anchors in Norway. The guys have been riding on it for 12, 15, 18 hours, high loads. In the end, you go down, you put on the brakes, and you try to tear this thing out because it simply won't come. There's a crew change coming. But the fatigue capacity of mobile chain is something we don't monitor. But it's something we start to look into, because we do have the data also from the rigs. But the recovery operation stands for 90–95% of fatigue damages on mooring chains. That operation alone. Yeah, this is just a summary. And this is something we're working on with some tests in Norway. They're also getting the logs from the rigs, and Delmar Intermor can then combine the fatigue data and actually get the full picture of what this chain has been subject to. Yeah, so that's basically me.
Thank you, Dagbor. It was very interesting. Always amazes me when I hear Dagbor speak, and just when I think there's no more you can know, you impress me with how much you know. It's good. Very good. Have you got any questions for Dagbor?
Joe.
Good afternoon. I'm Ian Finlayson from Shell. A couple of questions. One was, you mentioned about the high tensions there going over the roller, but what about over the Fairlead and the Gypsies when cross tensioning?
That's also bad. but the cross tensioning is not so high loads. You know, and also if you look to long-term units and also the mobile rigs, there is a reduction factor. I think it's 15% or something. It has been discussed whether that should be changed. It's normally a control operation, the cross tension. So that, something's going on there. So that the loads are not in 600–700 tons. Yeah, it's up to your operational, and you have good safety margins so long as the integrity of the chain is left. But of course, chain links that sits in the roller are the worst one for the actual rig. Yeah. So this is why we like to rotate those. We have problems in Brazil where they have fairleads on the long-term units and never pull the chain in. It's the same link taking all, but then actually wear is a bigger issue than tensions, because you've got one fixed link and one free link, and that causes wear. Somebody also in Stena knows that, so that's the mechanism. So normal operations, okay, it's the recovery operations that is actually killing the chain.
Okay, thank you.
Yeah.
One more question. Sorry. The Ramnes Brook chain, there was a paper about the Ramnes Brook chain from a few years ago. That was, don't know if it was pointed directly that there was an issue with that, but do you have any comment on that chain and whether we should be using that or considering not using it?
Yeah, you're talking about the Hercules chain, or you're talking about Ramnes in general? That was
the chain I'm considering is just supplied by Ramnes Brook, and it's been highlighted that that was pointed out as a particular issue. It wasn't directly stated, but it was implied. And does that mean that is now a concern? I have heard that some companies are starting to refuse it, and I was just looking for more of a general consensus on that, on whether you feel that is actually a threat or whether it is more to do with the R5 in general.
Yeah. As I said, R5 normally is used correctly. R5 is not a challenge. There may have been fabrication issues on parts, as I said, and now I have to be very, very careful, because what I have in writing is one thing, what I know is something else. So being me standing on stage, I can't answer all questions directly. But as I said, the R5 issues were the tip of the iceberg that triggered the industry to come together and start working. It wasn't really the Ramnes that was the problem, in a way. It was the way we were operating. But we can discuss the chain afterwards. Yeah.
Always good to start with an easy question, eh?
Yeah.
One more question.
Hi, I'm Katie Robinson, First Marine Solutions. I noted on the presentation the introduction of the new class notation, the T-log for the anchor handlers. Is the expectation of that is it to become an industry standard for the anchor handlers to have that capability? Because that's something I've definitely noticed in the industry, that often the vessels aren't capable of providing those tension logs.
Yeah, somebody started machinery, but I think I got the question here. Yeah, we're coming out with a new class notation called T-log. We haven't really marked it yet, but it's there, and it was also mentioned here. And that is basically to show that the vessel has calibrated load cells, it's set up, it knows its limitation, and it's technically possible for the guys on the bridge to extract those data. And actually, they also have. And again, we have to be careful, because there's very often one software supplier on these anchor handlers. It's Kongsberg for IP-Huset. They have a software upgrade that gives you the overview that's easy to extract. They can even put it to cloud-based. So we cannot write requirements for the whole fleet. So that's why I put this into a sort of a notation. So if you upgrade this software and you calibrate the winch, you can also. Some of the older vessels, the load cells are not fast, maybe 1 to 2 hertz. That's not enough to capture the peaks. Many in the fleet has 1 hertz, I mean 1 logging. That doesn't give you the peaks. So these systems will also have a higher, and Kongsberg can go in and change that, because the sensors are logging maybe 100 hertz, but the values displayed is once per second, yeah? So the vessel that has upgraded this, that we can put up on a specific class notation to show that this vessel can actually give Delmar and Intermor the information they need. And that could, of course, come into the specifications from the operators who's hired the vessels. So this is, but yeah, it's there, but they have not promoted it so much, yeah.